Exercise 1A sets from S Aggarwal book. Question number 4. Write the following sets in roster form. First question. A equal to set of all letters in the word letter. Let's start the solution. So our question was A is a set of all letters in the word letter. So now we will start see that how many words, how many alphabet letter in this word. This is L, this is E, this is T, and this is again T. So it's already here. E is again repeat. This is R. So L, E, T, R. These three letters are used in this word, and we can write this like that in a roster form. This is our answer. Let's come to second question. B is a set of X where X is a natural number less than 7. Let's start to write in a roster form. So our second question is B is a set of X where X is a natural number less than 7. We all know that natural number starts from 0 and so on. It's 0, 1, 2, 3 up to infinity is the natural number. Here our question is less than 7. So less than 7 is 0, 1, 2, 3, 4, 5 and 6. These are less than 7. So we can write this in a roster form like that. This is our solution of question number 2. This all are less than 7 and all are natural number. So let's start question number 3. Question number 3. C is a set of X where X is an integer and X is greater than equal to -2 and less than 5. So let's start to write this in a roster form. So our question is this. C is a set of X where X is an integer where X is less than equal to greater than equal to -2 and less than 5. If we will make number line, we will put 0 here. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. So our question is saying greater than equal to -2. So we will start from -2 because it is equal to -2. So -2, -1, -1 is greater than -2. So our X is -2, -1. And next is less than 5. So less than 5 is up to 4. So we will write 0, 1, 2, 3, 4. This is our X, and we can write C is equal to -2, -1, 0, 1, 2, 3, 4. This is our roster form of this question. Let's go to next question. Question number 4. D is a set of x where x is a prime number and x is greater than 60 and less than 80. Let's start to write in a roster form. So our question is D equal to set of x where x is a prime number and x is greater than 60 and less than 80. So prime number, we know the number who is divisible by two natural numbers, that is 1 and itself. So we will start from 60. 60 is divisible by then more than two natural numbers. So it is not 60, 61. 61 is divisible by only two natural numbers, that is 1 and 61. So yes, 61 is our number of x. 62. 62 is divisible by more numbers, 2, 4. So 63. 63 is again divisible by more natural numbers, 1, 3 and 63. 64 is again divisible by more natural numbers, 1, 2, 4 and 64. 65 is again divisible by more natural numbers, 1, 5, 65. 66 is again divisible by more natural numbers, 1, 2, 3, 66. 67. 67 is divisible by 1 and 67 only. So here we will write 67. 68 is again divisible by more natural numbers. 69 is again divisible by more natural numbers, 1, 3, 69. 70 is again divisible by more natural numbers, 71. 71 is divisible by 1 and 71 only. So here we will write 71. 72. 72 is again divisible by more natural numbers. 73. 73 is divisible by only 1 and 73. So this is prime number. 74 is divisible by more natural numbers, 1, 2 and 74. 75 is again divisible by more natural numbers, 1, 5, 75. 76 is again divisible by more natural numbers, 1, 2, 76. And 77 is divisible by 1, 11, 77. 78 is again divisible by more numbers. 79 is divisible by only 1 and 79. So this is also prime number. Again 80, we will not include 80 because x is less than 80. So we will calculate up to 79 only. So these are the prime numbers between 60 and 80. So we can write D is equal to 61, 67, 71, 73, 79. These are prime number greater than 60 and less than 80. So let's go to next question. Question number 5. E is a set of x where x is a perfect square and x is less than 50. Let's start to write in roster form. So our question is E is a set of x where x is a perfect square and x is less than 50. So we have to find perfect square between 1 to 49. So let's start. 1 is a perfect square of 1. 2 not perfect square. 3 no. Yes, 4 is a perfect square of 2. 5 not. 6 7 8 9 yes. 9 10 11 12 13 14 15 16 yes. Perfect square of 4. 17 18 19 20 21 22 23 24 25 26 27 28 29 25 is a perfect square of 5. 29 30 31 32 33 34 35 36 36 is a perfect square of 6. 37 38 39 40 41 42 43 44 45 46 47 48 49 49 is a perfect square of 7. So we can write x is equal to 1 4 9 16 25 36 and 49. And we can write, E is equal to 1 4 9 16 25 36 and 49. This is the roster form of this question. Let's go to next question. Question number 6. F is a set of x where x is a two-digit number. The sum of those whose digit is 7. The sum of whose digit is 7. Let's start to write in a roster form. So our question is, F is a set of x where x is a two-digit number, the sum of whose number is 7. Two-digit numbers. Two-digit numbers start from 10 and end at 99. So we will first see from this side. This side, can we get this more than 70? If we will take a number more than 70, can we will get sum of that number 7? No, because this is already 7, and if you will add anything thing on 7, it will be greater than this. It will be greater. 7 plus 1 8, 7 plus 2 9. So it will end here only 70. It will not go more than 70 because 7 plus 0 is equal to 7. If you will add anything in this, it will be greater than 7. So our last digit is 70. Now we will start from this side. 1 plus 1 plus 6 is equal to 7. So our first number is 16. To any other number we will add in 1, we will get 7. No. So it's till here only. 2 plus 5 is 7. So our second number is 25. If we will add anything on 2, we will get 7. No. So it's end here only. 3 plus 4 is equal to 7. So our next number is 34. 4 plus 3 is equal to 7. So our next number is 43. 5 plus 2 is equal to 7. So our next number is 52. 6 plus 1 is equal to 7. So our next number is 61. And 7 plus 0 is equal to 7. Our last number is 70. So these are 2-digit numbers whose sum of whose is 7. So this is our x. 25, 34, 43, 52, 61 and 70. And we can write this set into roster form F 16, 25, 34, 43, 52, 61 and 70. This is the roster form of this set. Let's go to next question. Question number 7. G is a set of x where x is an element of n, x is multiple of 5 and x square is less than 400. Let's start to write in roster form. So our question is, G is a set of x where x is an element of n natural number, x is a multiple of 5 and x square is less than 400. So let's start. Multiple of 5. Multiple of 5 means the number should be end by either 5 or 0. Number should be x square should be less than 400. So natural number, it starts from 0 and it should be multiple of 5. Multiple of 5 means 5, 10, 15, 20, 25. We will stop here and we will see square of 20 is 400. And our question is saying x square should be less than 400. So it means it should be less than 20 and it is 5, 10 and 15. X is equal to 5, 10 and 15. 5, 10 and 15 are multiple of 5 and square of 5, 10 and 15 is less than 400 and 5, 10 and 15 are natural numbers. So these are fulfilling all the requirement of question. So we can write G is equal to set of 5, 10 and 15. Let's go to next question. Question number 8. H is a set of x where x is a positive integer and x square is equal to x. So let's start to write in roster form. So our question is, H is a set of x where x is a positive integer and x square is equal to x. So let's start with positive integer means 1. Square of 1 is 1. It is fulfilling our condition. Square of 2 is equal to 4. Is there any other number whose square is equal to the same number? No. Only 1 is the number whose square is equal to itself, 1. So our x is equal to 1 and we can write this in a roster form. H is a set of 1. Let's go to next question. Question number 9. J. J is a set of x where x is an element of R and x square minus 5x plus 6 is equal to 0. Let's start to write in roster form. Yes. So our question is, J is a set of x where x is an element of R. R means real number. And x square minus 5x plus 6 is equal to 0. So let's start to solve this equation. X square minus 5x plus 6 is equal to 0. So we have to find two numbers whose addition or subtraction should be 5 and multiplication should be 6. So 2 and 3. Multiplication is 6, and if we will do like this, minus 3, it is also 6. So minus 2 and minus 3 is minus 5. It is here minus 5. Now we can write this x square plus minus 2 minus 3 x plus 6 is equal to 0. This is equal to minus 5. So we did this plus because minus plus is minus. Now we will solve this. We will multiply x in. So this is minus 2x and multiply with this. So this is minus 3x because plus minus is minus. Plus 6 is equal to 0. Now we will take out common factors. X is common here. We can write x minus 2 because one x is outside. Minus 3 is common in this. We can write minus 3. X minus 2. Minus minus plus, and 3x plus 6x is equal to 0. Now again the common is x minus 2. So x minus 2 and x minus 3. X minus 3 is equal to 0. We can write x is equal to 2, x is equal to 3. So these are our real number. X is equal to 2 and 3. And we can write J is equal to set of 2 and 3. Press the like button if you like the video. Do subscribe my channel to get the latest update, and don't forget to press the bell button. Have a nice day.